Let's talk tangents. Remember, tangent is the line that hits the circle in one place, but it's mostly outside the circle. So it intersects the circle at exactly one point. And that point, this point right here, is the point of tangency. A line is tangent to a circle if and only if it is perpendicular. Remember what that means. This line of tangency and this line perpendicular, so they form that 90 degrees with the radius. So if the radius and this line did not form 90 degrees right here, this line would not be tangent. So we can use that information to figure out if these lines are tangent or not. So we have our lines drawn. So we've got our tangent line AB, or we want to know if that line is tangent or not. So that's the line we want to know because that's the one that is on the outside, not going inside. So we need to figure out if, I'm pressing all kinds of buttons here, hold on. This line here and that blue tangent line, if they form 90 degrees right here. So we can do this with our right triangle Pythagorean theorem. If AB is tangent, then 8 squared plus 15 squared should equal my 17 squared. And if I do the math over here, this is 289 and this is 289. So they equal, yes, so yes, AB is tangent. So when asked if a line is tangent or not, this is what you're going to be doing. You're going to be putting in the Pythagorean theorem. Remember that the line opposite of that supposed 90 degrees is going to be our c squared. So we're going to see if this math works out, our Pythagorean theorem works out. So we can also use that if we know that our line JK here on the second example is tangent. That means that my 90 degree angle is right there, and I can use this to find x. I can figure out my Pythagorean theorem. We've got, this would be A, this would be B, this would be C. So I've got 11 squared plus x squared equals, okay, this is where this might trip you guys up. This 7 means from this side of the circle to K. That's not the whole LK. We need the whole LK. So what is L to the side of the circle? It's not 7. That would be an immediate response. L to the side of the circle is the same as L to J. It's a radius. So then that's 11. So that means our Pythagorean theorem is going to equal 18 squared. So when I do the math, and I've got x squared equals 203. To get x not squared, I'm going to take the square root. So x is going to be 14.2. All right. If two segments from the same external point are tangent to a circle. So we're looking now at this type of circle. So we've got this external point here, and we've got two tangent lines coming from that point. So if they're coming from that same point, then those lines are congruent. So this is the same as this. So for our examples, that means in this example, this line is going to be the same as this. So I can say 5x plus 23 equals 8x minus 19. Get x on one side by itself, x equals 14. Okay, this one same thing. We've got this external point, we've got our two tangent lines, so these have to be the same. So 10x minus 41 equals 4x plus 7. Do the math. X equals 8. But what if this question instead said to find SV, which is this line right here? So then we have to go back to kind of what we were doing before. We know that this is a right triangle, and this will be our A, this will be our B, and this would be our C that we're trying to find. So A would be 17 squared. I need to take what I found here, x, and plug it in here. And when I do so, that's 39. So 39 squared equals C squared. So this B is 39. So ST is 39, 17, and we need to find C. So whenever I do the math here, C is going to end up equaling 42.5. So our side SV equals 42.5. So you're going to see some of these questions and maybe a combination of these questions. Let me know if you have questions.